Good morning, students. Today's Wednesday, December the 2nd, and this is your warm up for the day. Just pause it right here, and then when you get done with these three questions, then you can unpause it, and then I'll go over the answers. Okay, students, the answers to these three questions are let me read it to you. Blank is a movement of rock or sediment. Okay, the answer to that would be erosion is a movement of rock or sediment. It's moving the rock or sediment from one place to another. That's called erosion. The next one is the breaking down of rock, and that would be weathering. Weathering breaks down, then the particles erode. And then number three, you can probably guess what that is the placement. Wherever the particles end up is called deposition. It comes from the word deposit. Um, so deposition is, and I'll go ahead and tell you, there's two different examples of deposition. One of them is a river delta, and the other one is alluvial fan that you'll see at the base of a mountain. Basically, it's just a pile of eroded material or weathered material and eroded. Okay, your objective today, students will be able to explain and describe the effects of weathering, erosion, deposition on the Earth's surface. The class will be doing a foldable, but we just put yours together as a set of notes. So, weathering is a process of either chemically or physically breaking down rock. And you see here some examples of that. This rock back here is weathering by chemical means because the oxygen is adding to the iron that's in this rock and causing it to weather. Okay, lichen up here is growing on this rock and it also helps it to weather chemically. This is an example. This could be just pressure being released and this rock cracks apart, or it could be because it's cold. The cracks get water in them and then it breaks apart because the water expands when it freezes, and that would be another type of a physical type of weathering. Two types, chemical and mechanical. Sometimes, and we'll call it in our notes, I think we're going to call it physical weathering. Perfect examples of something chemically taking place, and another one is him breaking the rock there, that rabbit breaking the rock by mechanical or physical means. We'll first start with this. This is a picture of a statue on top of, or part of a building, and it's only 100 years old. And it is happening because of basically it's acid rain, and everybody thinks acid rain is, they always ask the question, is it going to burn your skin? No, actually, acid rain is a lot less harmful than if it were raining lemon juice or lemonade or something like that. That would be a lot more acidic. So acid rain does, as it hits rocks and other things, it does slowly over time cause like this statue to weather, and by chemical. But anyway, chemical weathering is the breaking down of rock by chemically altering its composition. Rusting of rock, because iron is found in rock. Also bacteria could do it, or algae could do it. The agents, the substances, the chemicals that are going to cause this weathering to take place. So water dissolves it, and that is a chemical process. The second one would be, and these are good examples, so you can see how red these rocks are. They're not red because the rock is red. They're red because the iron is combining with the oxygen, causing the rocks to rust, which breaks them down chemically. Carbon dioxide also combines with water So the stuff in the air, not just oxygen, but also carbon dioxide. And it causes a weak acid. That acid causes rocks to weather. Also, as we've already talked about lichen, and we may have even mentioned moss to you, both of those produce very weak acids, but they weather, of course, this is on a stick, but it could also be on a rock. And wherever it is, it releases its digestive, basically their digestive juices that break down whatever substance it is, and it then absorbs those for nutrients. So lichen and moss. Also, as we mentioned earlier, acid rain. Acid rain, because of pollution, it will hit a rock or some type of rock and will cause it to weather by chemical means. So next is physical or mechanical, as I called it earlier. It's breaking down of rock into smaller pieces without changing its composition. So the rock is not rust any longer or something like that. It is just breaking it down. It's like you taking a piece of paper and tearing it in half. That would be a good example of physically changing the paper, not chemically. As I mentioned earlier, ice wedging. You have a crack in the rock. The water, as it rains, water fills up the crack, and because when it freezes and thaws over and over again, it just keeps wedging that rock apart more and more. The next one would be gravitational impact. If you have an avalanche, it's a great example of how the rock is going to. All this smoke is what it looks like there. That is just the dust. The dust came from this rock, so it's breaking down as it's going down the mountain. Abrasion. So water, believe it or not, is somewhat abrasive, and as it goes through an area, it cuts cuts its way through, and that is another example of physical or mechanical weathering. Also, heat. When something heats up, this is another example of physical weathering. Heat and expansion over and over again taking place causes rocks to, where it is, disintegrate, to become smaller and smaller. Also, exfoliation is where the layers, some rocks, because of a releasing of pressure, this is a good example. They peel apart like an onion would. And all it is the release of pressure. They're just rocks that are kind of stacked on each other, and the rocks don't stay perfectly still because of heat or maybe just the shifting of the earth. You get these layers pulling apart, just like an onion would. Here's a good video to watch. Watch this video. I'm obviously not going to take the time to watch it just because of the time limit. Weathering occurs more quickly in hot, humid areas, such as a rainforest. Okay, you would think it would be in colder areas, but really, this is the fastest weathering of rock if you were to put them in these two environments. Weathering occurs more slowly in cold, dry areas. Dry areas means that you're not going to get that water dissolving or freezing and thawing if you're in a colder area. Okay, so this is the definition. Erosion is a process of moving rock or sediment from one area to another. Erosion can change landscapes, change river courses, or sweep beaches into the ocean. Trees and plants can slow erosion, and this is a good point because some of your questions on your test are going to come from this. Trees and plants can slow erosion, and the very important part of it is by what? Their roots holding soil in place. There are 4 agents. Just as there were agents of weathering, there's also agents of erosion. And they are water and wind. Water in rivers moves sediment. So it's just the water's moving. You can see a river when it's really cloudy, and that's because it's got sediment in it. Wind. We all know wind can push sand, but it could push other rock particles around. But they need to be small, obviously, because wind would have to be pretty darn strong in order to move it. Ice. This is a very slow process, but this is a glacier. It may only move an inch or two a year. And then gravity. Gravity is very strong. So substances can go. This soil just went down the side of this hill and landed on top of this road, and it's going to be a lot to fix that road. So at this point, I'm going to give you a couple of seconds to figure out which will show the least erosion and why. So which one of these are containers that are on a slant. We're going to add water to them. Okay, let's say we add a bucket of water. I don't know, maybe half a gallon to each one. Which one is going to produce, basically, which one will show the least erosion? So the containers down here, whichever one has the least amount of soil in it, would have the least amount of erosion. So, give you a second to figure it out. So we'll just say this is A, B, and C. You tell me which one. So I'll give you a few minutes, pause the video, try to figure it out, and then we'll come back and answer it. Okay, back. So this one has the most vegetation. And because of it, remember what we said earlier, the roots are going to hold in the soil. So this one should have the least amount of erosion. On the other hand, down here, there's no vegetation. This would have the most erosion. So there'll be the most sediment here. There'll be a little less here and even less here. So that's the answer to that. There is a question on your DCA about that and also on your test. So just remember that roots kind of hold back the soil from erosion. And that's the reason why we put on a slope, we put some way to hold back that soil from eroding. Here's some pictures that are basically moving here, and you can kind of see the weathering and erosion taking place. Just kind of watch it a while and you kind of get to read all of it and see all of it. And the last one is deposition. I'm almost out of time, so I'm trying to rush through this. So deposition is a process of laying down eroded material into a new location. So these piles, this is deposition. It's moved its way down and deposited in one spot. Now it's going to erode again and deposit somewhere else every time it rains. Okay. Examples of water depositing sediment at the mouth of a river and forming a delta. That's a good example, and that will be on your test more than likely. A delta is a great example of a deposition. When moving a sand to form a sand dune, the sand dune is also an example of deposition. And alluvial fans, here's a mountain. This is the deposition that takes place. It's just the sand or rock that ends up going down the mountain. That makes an alluvial fan. Alluvial fans, some rocks are very soft, and it doesn't matter if it's on a mountain or not, but it's going to go down the hill. And it almost looks like a river delta at the bottom of a mountain. Here's the example. So this is this one is well, this is the delta. This is a river. You can see the river. And this is sand, so this is probably very shallow water, and this is deeper water out here. This is land here. So this land was right here, but now the land is starting to go way out here, and it's going to get bigger and bigger over time as more deposition takes place. So this is an example of deposition. All of these are. This is the alluvial fan, and it just looks, you would think it would be more spectacular or whatever, but all it is just the sand or the broken rock going down the mountain. And then this one would be the sand dune right here. Sand dunes get blown around over and over again. So this sand dune here may not be here in a year. It may be farther over, and it may not be of the same sand dune. All the grains of sand may be from different sand dunes. So anyway,